Come to our discussion. We will discuss matrices. In general, given matrix A as shown there, to get the inverse, that is inverse A, rearrange the matrix. Okay, rearrange as shown here. Introducing the elements of the leading diagonal, change the sign of the element of the second diagonal, then pre-multiply by 1 over determinant, where determinant is AD, product of AD minus product of BC. That is, inverse is equals to 1 over product of AD minus product of BC, shown here. The inverse changes as shown there. And then we continue. A matrix is singular if its determinant is 0. Okay, if AB minus AC is equals to 0, first row becomes the first column and vice versa. Adjoint is the inverse without the determinant. You can see here, inverse without the determinant. Solving simultaneous equations by matrix method. You see this procedure. Write the pair of equations in the matrix form. Okay. 2. Pre-multiply both sides of the matrix equation by inverse of the coefficient matrix. And 3. Multiply the left side of the equation with the identity matrix. And lastly, equate corresponding elements to get required solution. Let's look at this example. This matrix method to solve the simultaneous equation. We remember the procedure. First, you rearrange in matrix form. You get like this. Rearrange the equation to get. Okay, write this equation in matrix form. Okay, take the coefficient matrix. The coefficient matrix is that determinant is equals to 8 minus 15. That is negative 8. Where we get is negative 2 times 4 minus 3 times 5, that is negative 15. Okay, we get, it will be negative becomes positive, so it will be negative 8 plus 15, you get 7. Inverse is equals to 1 over determinant and then the coefficient matrix. Okay, we'll get the inverse. Multiply both sides of the equation 1 by the inverse. We got the inverse of this one, then we multiply by the equation itself. Okay, we get something like this. Then we continue. Okay, you can see 7 goes to 14, 7 goes to, so our x is equals to 2 and our y is equals to negative 1. If you have not understand, you can go through it once again. Very simple. Let's look at this example. A cloth dealer sold 3 shirts and 2 trousers for 40 shillings and 4 shirts and 5 trousers for 1,680 shillings. Form a matrix equation to represent the above information. Hence, find the cost of one shirt. Okay, equation we will do it. We say let shirt be S and trouser be T. Become 3S plus 2T is equals to 840. 4S plus 5T is equals to 1680. We rearrange at this and we find the determinant, which it will be 18. 15 minus 8 we get 7. So we say 1 over 7 is equals to 5 over negative 4. 5 negative 4 negative 2 3. We multiply by x and y, which x is equals to S shirt, y is equals to trouser. Get 84 0. Then if you want to multiply, we do row times column. Yes, and then we come, we say is equals to 5 times 84 minus negative 2 times 1680. You get is 4200 minus 33 60. You get is 7560 divided by 7, and then we get our x as 1080. We look now for y, which is trouser. It will be negative 3360 minus 55040. we get 8400 divided by 7, we get y, which is equals to 12, so is equals to 1260. And with that, we have come to the end of our discussion today, which was matrix. Remember, if you can send your request through my WhatsApp for any complaint. Also, you can contact me through my WhatsApp. For now, it's a good boy, and remember to subscribe and share. Bye.